Okay, so as I was saying in the previous slide, this integral, for this, we have to use Feynman parametrization for second identity with n1 and n2, given by 2 minus d by 2 and 1. So we will use this identity here. So let me write down the result here. So gamma 2 minus d by 2 divided by 4 pi to the power d by 2 integral dx 0 to 1 minus x to the power d by 2 minus 2. So gamma n1 plus n2 by gamma n1 times gamma n2, that is how the expression result starts, and the prefactor is that one. So n1 and n2 is 2 minus d by 2 and 1. So gamma 2 minus d by 2 plus 1 divided by gamma 2 minus d by 2 times gamma 1 times d alpha 1, which I call y, and downstairs we have a1 times, so a1 is this factor, this times alpha 1. Alpha 1 is y plus 1 minus alpha 1 times the other factor a2, L square plus, which is L square plus m square, to the power n1 plus m2, 2 minus d by 2 plus 1. Upstairs we have alpha 1 to the power n1, which is y to the power n1 plus 1. So n1 minus 1. Let's check that. n1 minus 1. So that's 2 minus d by 2 minus 1, which is 1 minus d by 2. Times alpha 2 to the power n2, but n2 is 1. Alpha 2 to the power n2, alpha 2 to the power n2 minus 1, alpha 2 is 1 minus y. But n2 is 1, so this is to the power 0, so I don't have a factor there. And then as earlier, we just expand this and write it as L square plus something. So what you can show is that I'm not going to do the calculation fully, but what you can show that this is same as y L plus yp whole square plus y times 1 minus y times p square plus m square 1 minus y plus y by 1 minus x. Okay. Then this result is given by gamma 2 minus d by 2 cancels here. We have gamma 1 is 1 and gamma 3 plus d 3 minus d by 2. So gamma 3 minus d by 2 divided by 4 pi to the power d by 2. Integral dx 0 to 1 times ddl over 2 pi to the power d L square plus p square y times y minus 1 1 minus y plus y by x times 1 minus x 3 minus d by 2. Using the same procedure that I discussed for the calculation of Kp, you can show this result. And now this last integral is just in the form of I1 L square plus m square to the power capital A, and we can just take the result, the one that I quoted there. This result. This is what one gets. So this is this gamma factor, which is gamma a minus a is 3 minus d by 2. It is gamma a minus d by 2 divided by gamma a. And we identify L square plus m square. This is m square to the power d by 2 minus a. So let's check that. So m square to the power d by 2 minus a divided by 4 pi to the power d by 2. So this is what I have written here. Yeah. So this is d by 2 minus a and divided by 4 pi to the power d by 2. So that's the full result. 3 minus gamma 3 minus d by 2 will cancel here, and this is gamma 3 minus d. So this is the result of the integral here. So so far we have been calculating this integral, and that's the result. But actual calculation, actual quantity we're going to calculate is this one, which is minus half p mu del p mu acting on that. So p mu k mu of p is equal to minus half p mu del p mu acting on gamma 3 minus d divided by 4 pi to the power d. And this result is minus half p mu. This derivative will act on this p square factor, which is here. So it is d minus 3 and this to the power d minus 4, which will come inside the integral, but outside we can take derivative of this with respect to p, which is p mu y times 1 minus y. So let me write 2p mu here. Then we write everything else within the square bracket gamma 3 minus d 4 pi to the power d. When we take a derivative of this with respect to p mu, we get 2p mu times y 1 minus y. That fact we have written only 2p mu, so we have to write y times 1 minus y. And then y to the power 1 minus d by 2, which was there earlier also. So this factor times p squared 1 minus y plus m squared 1 minus y plus d minus 4. So this p square, this p mu gives p square, and this 2.5 will cancel. So it is 3 minus d. So p square times 3 minus d times gamma 3 minus d divided by 4 pi to the power d integral dx 0 to 1 d by 2 minus 2 dy 0 to 1 So that is a final result. So we have, in addition to the previous results for I1 and I2 given in these equations, these two equations, we have one more result for I3, and let me write it down. Yeah, so let me summarize the result here. the third result, I3. I3 is given by integral d L1 2 pi to the d L2 by 2 pi to the d times L1 square plus m square inverse L2 square plus m square inverse e plus L1 plus L2 whole square inverse. It is given by minus 1 over d minus 3 times 3 m square kp plus p mu k mu p, where kp this p mu k mu, which is p mu del p mu, acting on the quantity, which this quantity is precisely I3. So the result is given by p square three minus d gamma 3 minus d 4 Okay, that's the result. And yeah, so these are the two slides. This is the result for I3, and we will use this I1, I2, I3, these results while calculating Feynman diagrams in phi-fourth theory that is required for renormalization of that theory. Okay, that's what we will start seeing next time. Okay.